Hey guys! Alright, so today is the last episode of the Let's Write an ECS mini-series, and if you didn't see the previous episode then I'll link it above and you can go and check that out. But today we're going to be focusing on performance, and we're going to be benchmarking our ECS against a very popular ECS called Entity, or ENTT if you want to spell it. We'll also be benchmarking against a more conventional method of just a vector of entity pointers that points to different structs, effectively, of entities. And I think the results are pretty interesting, so stick around and check it out. I've written all the benchmarking code already, so we're just going to go through the tests. We're going to compare the baseline, and then we're going to add some performance optimizations to our ECS and discuss the kind of memory and CPU performance trade-offs. So let's do it. All right, here we go. So first of all, let's just go through some extra bits that I've added. So I've added some unit tests because I'm going to be making some changes and I need to make sure that I don't break the existing functionality. And yes, they're all very simple, pretty much just doing what the test app did before. And yeah, I've pulled it out. Secondly, I've now got a vendor folder because we're going to be comparing ENTT, and we're going to also introduce some new data structures. And here is our benchmarking test app. So initially, let's just kind of go through it. We're just going to do 5 tests, and these tests are iterating over n number of entities with one specific component, delete approximately 60% of the entities, and then iterate over n number of entities again with one specific component, and then the same thing but with 2, 3, and 4 components for that entity. Now, we'll be testing against a vector of malloc entities and ENTT as well, or entity. There are plenty more tests I could do. This isn't like a fully fledged benchmarking video. It's purely just to kind of explore, have some fun, understand where the performance issues are, and also more importantly, understand how to improve it and maybe why something is slow. So that in the future, if we do hit some bottlenecks, we can think back to this and be like, yeah, that sucks or whatever. So yeah, we could do kind of insertion time tests, deletion tests, entity destroy time tests, specific fragmentation tests if we're destroying a lot of entities at different rates and things like that. And like I said here, we're not trying to be world class. We're just trying to learn, basically. So a bunch of jumbo there. A timer class, this is what I use to kind of benchmark, and it just uses the high performance counters from Windows, where you just kind of query the performance counters and then convert to time depending on the frequency. And these are the components that we're going to use, just an alias for a map4, animals, animal food, animal habitat, and animal hairstyle. This is the struct that we're going to be using as the plain old struct that I mentioned before. It's just an entity with an ID and then 4 optional components, which we can check to see if this kind of entity has those values. This is the animal system. If we just look to the first one, very similar to what I showed in the previous videos, the animal system can be pulled out of the ECS and we can call iterate. Let's get rid of that. We can call iterate, and then we can iterate all over all of the entities and get our component out and do stuff to it. And then there are different iterate functions. So iterate 1, iterate 2 components, iterate 3 components, and then iterate 4 components. And then this is where the main stuff starts. So we do all the ECS setup. I'm not going to show you that. We did it before. Test constants. At the moment, we're just doing 10,000 entities, which isn't a lot, and we can change this later maybe, but we do that 1,000 times effectively to make sure that we kind of balance out the benchmarking. Then we start with the test. So test 1, this is where we set up our ECS, we add all the components, we then get the system out and we start iterating, and we kind of capture data points and then print the average time. And then the same for vector of entity pointers. So with this, we just have a vector of animal collector entities. We place back new animal collector entities, and then we effectively assign components to each of those optionals. We then iterate and we print. And then the same with ENTT. We register dot in place. We then call the way that entity works or entity works, and which is where you get a view and then you iterate over the view with all the entities, and then you can pull out the component. And then we've got test 2, which we delete approximately 60% of the entities. And I do that by just effectively iterating over the test entity count, then calling roll, which is a random number generator. If it's less than or equal to 6, then we destroy from every kind of system. So our system, entity, I need to say entity, and then we just delete the pointer entities inside the animal collector vector and set it to null. And then we do the same thing. We basically call the same iterate function and do the same with the vector of entities and then entity as well. And this just shows the performance based on after deleting entities. So kind of, do we flatten the, do we make sure that the entity or the component vectors are packed enough to keep the performance there effectively? Then test 3 is exactly the same as 1, iterate over 2. Test 4, iterate over 3 components. And then test 5, where are we? Iterate over 4 components. So iterate over 4 is just called there. Vector of entity pointers, we basically check that the entity is valid, and then make sure that the component isn't null opt, basically a null optional, and then we do stuff to it, basically like get the value out and then do stuff. And then very similar in entity, we create a view of these 4 specific components. We kind of get the component out, and then we adjust the component in exactly the same way as we do it here, and we do it here. So, and then that's the test complete. So I suppose let's make sure it's built. Built app release. We've built a release version. So let's run it and we can look at the results. So here we go. Iterating over n number of entities of one specific component. Our ECS, 140 milliseconds. I think this is milliseconds. Let's say it's milliseconds at the moment. I'm going to double check. Timer. Yes, okay, sorry. This is microseconds. So we get the amount of ticks that have happened between now and the start time. We convert to microseconds, and then we divide by ticks per second effectively, which is the frequency. So let's go back to our results. And as you can see, our ECS took 140 microseconds to iterate over 10,000 entities with one specific component, whereas a vector of entity pointers took 49, and then ENTT entity took 44. If we delete 60%, our 61, vector of entity pointers 24, and then ENTT 16. And then the same story for the rest of it, effectively 105, 147, 188, 27, 29, 32, 38, 48, 58. And as you can see, kind of, they all go up linearly with the amount of components, which makes sense. So 10 seconds, 10 microseconds, 10 microseconds, 10 microseconds. And then this one is, the vector of these are 2 microseconds, which is impressive. And then ours is like 40 microseconds, which isn't so impressive. So first of all, what we're going to do is we're going to improve that. And the way that I have done that is, if we just look at what we're actually doing when we iterate, this is the function we've benchmarked, right? And what we're doing, we're iterating over entities, which is a stood unordered set, and then we're getting a component, which, if we follow through, we get a component array, Why is that taking me there? Okay, let's do it this way. We get a component array, and we get component here, and then look what we're doing. We are hashing our entity ID into an ordered map, and then we're pulling out the component from the vector. So this is quite an expensive operation. With like every time we want to get an entity, we have to hash the entity ID, look into the map, which isn't a packed, like a sparse set, which has like a packed vector in it. And that's quite an expensive operation. So one thing I've done initially to get rid of that is I've just swapped to a plain stud array that can take all of the max entity count, which is the size of the max entity count plus 1 because of reasons. And this will be our map. So all we need to do is we need to index into an array, which requires no hashing, and we'll see how that performs. Here's something I prepared earlier. I think that's everything we need to do. That there. So let's just build that. So let's discuss this quickly. This isn't great for kind of memory usage because now every component array has a fixed size array of the maximum amount of entities that is possible, even if that component array only ever has 2 or 3 entities in it, which is a big shame because that's kind of a lot. But if we do the maths on it, let's say max entity count at the moment is 100,000. So we've got 100,000 entities, 100,001 because plus 1 of size t, which is 8 bytes, right? So we've got 800 kilobytes per component array. And let's say we've got 50 components and therefore 50 component arrays. That's 40 megabytes, which we can half already by just changing the uint, by just changing the amount of entities, the max entity count, where is it in constants here, to uint 32. And that goes to 20 because then we've only got 4 bytes per component array. And at the moment, I just don't see that being an issue. Kind of, if it becomes an issue in the future, then we'll solve it. But right now, I think I'm happy to kind of take that hit. So what is happening? There we go. So let's now run our tests again. So here we go. You can see that now because we've just switched to, we don't need to hash, and the array, both the array and the vector are contiguous in memory when we iterate over them. You can see that we've significantly reduced our time, right? So previously we were 140 microseconds. So now we're 39 and kind of beating, like I'm not claiming that I'm anywhere near as good as the entity library because the entity library focuses on both speed and memory. But for now, we can iterate faster. Then when it comes to deleting approximately 60%, we're still a bit slower. I'm not really too sure why, but there's something that we can do here to kind of improve this. And then 2 components, 25 microseconds, 3 components, 31 microseconds, and then 4 components, 36 microseconds, which I think is great. We're now a lot quicker than we were previously. So previously, with 4 components, we were disappeared. Let's do this one. With 3 components, we were 147 microseconds, and now we're 31 microseconds. Just from a very simple change. But there's also still some more optimization that we can do. So here, if you notice, we're iterating over a stud unordered set, which again, isn't contiguous in memory. So there's probably a lot of memory jumps going on. And I've brought in an unordered dense set from Ankel, which or anchor L. I'm not sure how you pronounce it, but the underlying data structure in this involves, I'm pretty sure it's a sparse and a packed array or vector. And therefore iterating is super quick because all you're doing is iterating over the packed vector. And if we build this now, it has the same API, so you can literally just swap it one for one, which is great. If we build this, maybe let's put another terminal in the way. Is my face in the way? Choose the wrong one. There we go. And now if we run this, let's compare the results. So here you can see we now iterate a little bit quicker, but we have to obviously be careful because this run is already quicker all round. So even entity is quicker, and the vector of entity pointers is quicker, 54, 48, 48, 45. Then when it comes to deleting approximately 60%, I think this is a fair assumption. We have definitely improved in speed here because now we're iterating over this kind of flat entity struct. Here, 2 components, 17, 26, 41, 25, 27, 37. 3 components, 23, 31. That's good. I don't know why that's disappeared for ENTT, but oh well. And then for 4 components, 23 microseconds, 34, 34, and 58, and 56. So like again, another significant increase in speed. So I think I'm pretty happy with that. And let's just make sure that we can run all the tests. Again, run. Yeah, everything's happy, right? We're all happy. So you can see here, just with some simple optimizations where you kind of really think about what you're actually doing. So here, now we're iterating over a vector instead of an unordered set, which is effectively an array of buckets which are linked lists, right? So it's not very efficient doing that. And also the same way, when we've changed the array here to an entity index map, look, we've taken the hit with memory, but the performance is significantly increased. And until potentially that memory kind of becomes a big issue, then we'll just leave it and we can fix this later on. And I think probably the way to fix this is to use a better hash map here, and one that has an underlying packed array, probably very similar to what we're doing here, because unordered dense has a map, which again has an underlying vector. And then what we can do is, instead of kind of getting components, we can just return the iterator to the underlying packed array, and then all you do is iterate over the vector, which is great. Becomes a little bit more tricky when you're grabbing 2, 3, or 4 more components, because you then need to kind of orchestrate those vectors and how you're getting things, which is probably why entity is slower here, because for us, we're just indexing into arrays, and that's very, very quick. But entity is doing that orchestration, using maps to create this registry view of all the entities. So there we go. We've managed to improve the performance of the ECS that we write. We did take a big hit on memory, quite a big hit on memory, but we managed to improve the speed, which is always generally the trade-off you generally have to make when you're doing this sort of optimization. Do I use more memory and get more speed through kind of caching or arrays, for example? Again, just to reiterate, I'm not trying to make the best ECS in the world. I'm not trying to compare myself against the really well-written entity library. I just wanted to benchmark how we kind of compared against a vector of structs, for example, or a vector of struct pointers, and entity and make sure that we weren't just completely in the wrong ballpark for how our performance was. If we were to do more benchmarking, kind of deletion, insertion, fragmentation, adding and removing individual components on entities, and then iterating, I guarantee that we would have to optimize again. So this was just a very simple set of optimizations. If you do want to use a library that is very well written and optimized and fast, then please go and check out Entity. I'll leave the description or the link in the description, and you can go and look at it. It's great, and the documentation is fantastic and explains everything really well. So please, yeah, go and check that out. If you enjoyed this video, or you learned something, or you didn't learn anything and you want to tell me how rubbish I am, then please like, subscribe, and leave a comment and let me know what you thought. I really appreciate it. That's it for today. Cheers.